Hi there! In this video, we're going to learn how to write a function as a composition of two functions. So what does that even mean? I'm going to take a complex function and I want to learn to be able to see it as two functions put together. So I have one function and then something substituted in for my variable of that function. So that's exactly what function composition means, is something plugged in to a parent function. So let's just break this down, because there's lots of word functions going on. It kind of sounds really confusing. So let's first just talk about basic function composition to kind of get you in the groove of what we're going to do, and then we'll learn how to break apart a function. But first, I just want to remind you of our basic parent functions, which are like the most broken down, basic types of categories of functions that we have. So like this first one, y equals x, is our basic linear. Y equals x squared is our basic quadratic. Y equals x cubed is our basic cubic, or to the third. Y equals absolute value of x. We have the square root of x, the cube root of x, and then over here, I put to the nth power because my degree can be higher than 3. It could be 5, 6, 7, 8, 9. I can keep going up as high as I want. And then also my index here, I put to the nth index because I can have a root that's higher than a cube root. It can be the 4th root or the 5th root, even higher if you want. So you're looking for something basic like that, and we're looking for something plugged in to that. But we're going to just start with basic function composition here, just to kind of get you in the groove of like function composition. So in this first function problem, I want you to write f of g of x. So that means I'm going to take my function g, and wherever I have an x, I'm going to plug it into my function f. So that means that I'm going to write my f as a skeleton. So I'm going to say f of g of x is equal to, now wherever I have an x, I'm just going to put a skeleton squared. Now where that x is, here, that means I'm taking my whole function g and I'm writing it here. So this is going to become 5x plus 2. So what I did is I took this here and I substituted it in for my x value there. So you can see that here is your x squared, and then this is what I substituted in for x. Okay, let's try writing it the other way. G of f of x. Also, by the way, please note that this notation, because some textbooks use this notation, this is saying same thing means the same thing. We say this g of f of x, g of f of x. It means that I'm taking this function that's next to my x and I'm plugging it in the one on the outside. Okay, so now I'm going to take my function f. So I'm going to take this x squared, and wherever I have an x here, this whole thing is going in here. So I'm going to write out my g function as a skeleton. So I'm going to say that g of f of x is equal to my function g as a skeleton. So 5 times x plus 2. And what I'm putting in place of x is my function f, which in this case is x squared. So here, I'm going to write x squared. Okay. So that's writing function notation. So now what I want to do is we're going to do the reverse of this. We're going to look at a function like this, and can you tell me the two functions that made this function? Okay. So I color coordinated it for you so that it's kind of easy to see, and like when you're learning how to do this, to kind of pick out what's my function I'm plugging into and what's the function I'm plugging in. Okay, so if you look here, we have to read what this complex function is. This complex function is capital H of x. So that means that I'm taking my function g is what I'm plugging in, and my function f is what I'm plugging into. So in this case, my g is going to be my green guy. So I'm taking my function 3x minus 5 and I'm plugging it into my big function. Now remember, when we set up our skeleton, you want to think of this pink is my skeleton. My skeleton says something, which in this case is x to the 6th power. So if I was to go and say, I'm going to write out my skeleton, f of g of x, okay, I'm taking my x function to the 6th power, and then I'm plugging in 3x minus 5. Okay, let's try again. So I have h of x is equal to the cube root of 6x plus 1. So remember, the g is the function what I'm plugging in. So I'm plugging in 6x plus 1 to my skeleton, which in this case is the cube root of x. Because you have to remember, this would be an x here, so wherever you would put a parentheses, that is what the x value would be in your parent function, or what you're plugging into. Okay, this one's a little bit trickier. So what am I plugging in? I'm plugging in x to the 3rd into my function 5, whoops, sorry, let me change colors. 5 times my skeleton plus 2, but remember my skeleton is just going to be my x. Okay, so let's see if you can do this now, identifying it without the colors, because that's a little bit harder. Same process, same concept. We know that h of x, sorry, I don't know what that line was. H of x is equal to f of g of x. So the g is what I'm plugging in, and I'm plugging it into my function f. So write out your skeleton. This is how I would do it. 2 times, I plugged obviously something in here, minus 2. So what did I plug in? I plugged in x to the 7th into my function 2 times x minus 2. Because remember, wherever you have this, your skeleton becomes an x. Let's try again. Okay, so what am I plugging in? It looks like I took this and I plugged it in. So this would become the cube root of, what am I plugging in? I plugged in 7x squared minus 5 to the cube root of x. Oh, that's really sloppy, sorry. To the cube root of x. Okay, try this last one. What are you plugging in? This one's already kind of set up as a skeleton. To what function? So I'm plugging in 2x minus 8 to my skeleton to the 7th. So this would be x to the 7th. So try and think of it as, where would your skeleton go? And then what is going in that skeleton part? I think that will help you identify what you're plugging in and what you're plugging it into. Okay, and make sure that you look at the directions so that you can identify the proper function. So like in this one where it said h of x is equal to f of g of x, you want to make sure that you're identifying the g is what you're plugging in into the f. Some directions might be different, and they also might write it using different notation. They could write it like this, f of g of x, which means the same thing, but they also might flip it around. So be careful on the directions so you know that g in these problems, g is the function that I'm using to plug in, and I'm plugging it into my function f. Let me know if you have any questions. Good luck.